Okay, hello again. This is the second lecture for the second quiz. This lecture is over space. And no, I'm not talking about the final frontier. I'm talking about illusionistic space on a two-dimensional picture plane. A picture plane is basically the piece of paper that you're making a drawing on or the canvas that you're painting on. Most drawings and most paintings deal with creating an illusion of space on a flat surface. That's really important to understand. A little bit later in the semester, we'll look at an artist, Jackson Pollock, who was one of the very first artists to make a painting that wasn't about an illusion of space, but about the actual surface of the painting. So when you think of a drawing or a painting, think of the piece of paper or the canvas as a window that you're looking through into an illusion of space. Okay? So there's the most basic way to organize space on a two-dimensional picture plane is using these three different areas of space: background, middle ground, and foreground. And of course, you can all probably guess which is what. Background is something that's behind everything. Middle ground is something that, well, let me go up. Background is something that's behind everything. Foreground is something that's in front of everything. And the middle ground is what's in between the background and the foreground. Foreground is the space in which the objects that are closest to the viewer exist. Since it's the closest to the viewer, it's going to have the most detail. So if you had a painting of bricks where the bricks were supposed to be 3 feet away, you're going to be able to see all of the details of the bricks. But if you had another painting of bricks where the bricks were 100 feet away, you're going to see less detail because they're further away. The human eye can't pick up details from something that's far away. So therefore, foreground objects have a lot of detail. And they're almost always at the bottom of the picture that you're looking at. And the reason for that is simple. If you are, well, okay, if you're sitting at a desk right now watching this video in front of a computer, the thing that's the closest to you, or at least to me, is my keyboard and my mouse. Okay? The thing that's the furthest away from me is the wall in the room that I'm in, that I'm facing. And the computer just happens to be in between the keyboard and the wall. Okay? Now, if I were to hold a camera up to my eyes and I took a picture, and then I had a picture in my hand of what I'm looking at right now, the keyboard and the mouse, which I've just said are the things that are the closest to me, are going to be at the bottom of the picture. Okay? And conversely, the wall, which is the furthest thing away from me, is going to be where? Well, it's going to be almost everywhere because it's a wall. But it's also going to be at the very top of the picture because it extends above the computer screen that I'm looking at. Okay, so going back just quickly. Foreground, it's almost always at the bottom of the picture. Middle ground, ironically, is almost always in the middle of the picture, but it can be at the top or the bottom. It's just most of the time it's usually in the middle. And background has the least amount of detail, which I talked about with the bricks, and it's usually at the top of the picture. In fact, it's almost always, unless you've done something tricky to try to break the rules. If you go outside and you take a picture of your backyard, or it doesn't matter what it is. What is the thing that's going to be the furthest away from the viewer from the camera? no matter what. The sky. I mean, literally, that's the furthest thing away from your eyes or the camera. And the sky is going to be able to be found at the top of the picture. Okay? The sky is not on the ground. It's up high. It's at the top of the picture. It's the furthest thing away. Also, sometimes with background areas, you get atmospheric perspective. Atmospheric perspective is something that happens to objects that are extremely far away from the viewer. The best example of atmospheric perspective is if you're out west and you see a mountain that's 100 miles away. What color is that mountain going to be? It's almost always going to be blue or violet, or somewhere in between blue and violet. And that's because there's enough atmosphere in between your eyes and that mountain that you see that atmosphere. Okay, so if there's dust in the air, that creates, or if there's moisture. I mean, the reason that they're blue or purple, I believe, is because of the humidity in the air. You actually see that atmosphere, and that's called atmospheric perspective. And we'll talk more about that in just a little bit. So just because we know that there's a background, a middle ground, and a foreground, that doesn't mean that we know how to represent that on a two-dimensional picture plane. But there are some ways, some tricks that an artist can use to make those areas of space more identifiable, I guess. Sharp and diminishing detail. Okay, if something is really up close to you, you're going to see a lot of detail, sharp detail, and you're going to see all of the detail. The further that object gets away from the viewer and heads into the middle ground and the background, that detail begins to diminish. Okay, and that's what I was talking about with the bricks earlier. Atmospheric perspective. We already know what that is. If you're out west and there's mountains around, if a mountain is really close to you, you're going to see the true colors of the mountain. You're going to see the green from the trees, etc. And you're going to be able to see a lot of detail also. If the mountain is extremely far away, you're not going to see that detail because of this rule here, diminishing detail. And the atmosphere is going to change the way that the mountain looks. Okay. Size relationship, also called diminishing scale. If you have telephone poles, if you're standing on a road and you can see telephone poles going down the road, the telephone poles that are the closest to you are going to be the largest. The ones that are the furthest away are going to be smaller. So size relationships, that's a way to show space. Position on the picture plane. We know that from middle ground, background, and foreground. If something's at the bottom of the picture plane, it's going to be where? In the foreground. If something's at the top of the picture plane, it's most likely going to be in the background. Also overlapping. If you have different objects that overlap one another, that can show space. So basically, if you hold your two hands up in front of your face and put one in front of the other, you're able to see all of the hand that is in front of the other hand. But it also obscures the hand that's behind it. So by overlapping, if you can see all of something, you know that it's closer than the same object or a different object that's being obscured, that's being covered up. The last two are the most complicated. They're the most technical or scientific. Linear perspective, that's a drawing device where you use horizon line and vanishing points to make a drawing. And I've got some pictures a little bit later on in this lecture that'll help make that make a little more sense. And also, we will be doing some perspective drawings. Warm and cool colors. Warm colors are colors like reds, orange, yellow, and cool colors are colors like green, blue, and violet. Warm colors, when the eye looks at a warm color, that object or that area of color appears like it's coming at you slightly. It's not, I mean, I'm not talking like a three-dimensional, like a 3D movie or anything like that. I'm just saying that if you have a poster and there's a red car on it or something, when you look at it, subconsciously, that red car, because it's red, your brain thinks that it's coming at you. Not literally coming at you, but just that's the first thing that you see. Cool colors, on the other hand, they recede. They do the opposite. They almost want to go back into space. So if you had a painting with two squares that were the exact same size, okay, so we know that most of these rules up here won't apply because they're the same size. We don't have diminishing detail because they're the same size. We don't have diminishing scale because they're exactly the same size. They're right next to one another, which I didn't mention, so we don't have the position on the picture plane. They're not overlapping each other, and there's no linear perspective use. So how do we show that one is closer than the other? Well, you could paint one of them red and one of them blue. So then the one that's red, it feels like it's closer because that color wants to come off the page at you. And then the blue one will almost recede back into space. And here's what I just got through. I didn't realize that this was on here. I guess I could have saved my voice a little bit, but here's further descriptions on all of these ways to show space. We have diminishing detail, atmospheric perspective, and here's an example of atmospheric perspective. This is a really bad picture. I apologize, but you can see that there's, I don't know if these are clouds or if they're mountains, but let's look at this area right here. These plains back here, we're looking down from a high point onto this hilly area. You have, well, let's just go all the way up to the front. Okay, right here you have all these rocks here. These rocks here in the picture are probably very similar to whatever is right here, okay? Way out here. We can see all the detail, or most of the detail on the rocks right here. We can't see any detail here, none. So we have diminishing detail. We have the size relationship, diminishing scale. You can see right here. You have this rock outcrop here, which is much smaller than this rock outcrop here on the picture because it's further away. But going back to atmospheric perspective, if this area right here, this little bump, which is a hill way off in the distance, if it's exactly the same as this rock outcrop right here, there's a lot more darker values here. I mean, this is black, basically. There's nothing dark here. There's just a little hint of value right there. That's atmospheric perspective. The further something is away from the viewer, the lighter in value it becomes. You can see it right here in these trees. Like, look at these trees right here. You have some really dark value. But then look at these trees right here. They're much lighter in value. So that's caused by the atmosphere being in between the viewer and the actual object. Linear perspective. It's a device used to create the illusion of space on a two-dimensional picture plane. There are three main types of linear perspective: 1 point, 2 point, and 3 point. All of them deal with something called the horizon line. Now, the important thing to remember about the phrase horizon line is it doesn't necessarily refer to the horizon. You know, if you're out in the country and you look at where the sky meets the earth, we call that the horizon, right? Well, the horizon line doesn't necessarily have to be on the horizon. It's basically just wherever the viewer's eye level is. That's the horizon line. And then on that horizon line, you have things called vanishing points. In 1-point perspective, there's one vanishing point. In 2-point perspective, there's how many vanishing points? There's 2, right. In 3-point perspective, there's 3 vanishing points. And that's where all horizontal and parallel lines appear to converge to, are these vanishing points. And I think on this next slide, we'll be able, no. No, okay. It's a little out of order. It's in order, it's just not where I thought it was going. So we'll get back to linear perspective in just a minute. So here we have size relationships. You can see there with the wind turbines. Also here with you have this little sailboat here, and you have these other sailboats which we're assuming are the same kind of boat, but they're much smaller. And also there's atmospheric perspective involved. You have much darker value in this boat that's up close, very little value in the boat that's way back there, and diminishing detail. There's no detail. Okay, so back to 1-point perspective. In 1-point perspective, all parallel and horizontal lines recede to a single vanishing point that's on the horizon line. So this is the vanishing point right here. The horizon line goes right through that vanishing point. Okay? So if you drew a square here, just imagine that this isn't a cube, but you drew a square. Then to get these lines that represent the sides, the side and the top of this now cube, you connect the corners to this vanishing point. And then this line here, the back edge of the cube, it has to be parallel with this edge because it's a cube. So this line doesn't have anything to do with the vanishing point. It's just these lines that recede, and they are parallel with each other. Okay, so we know that from this one vanishing point, you can make these 3 lines right here. This line, and this line. The most common time that we see 1-point perspective in nature is if you were to stand on a railroad track and look straight down the tracks. Okay, you have a vanishing point which is right here, and that's also the horizon line. The horizon line is right here. Okay, because that's where that vanishing point is. So the person's eyes are right here, in the person taking this picture, the center of the camera lens is right here. Okay, if you were to get on a ladder and suddenly become much taller, you would be able to see more of the train track than right here. If you were to shrink down, then that horizon or the vanishing point might end up being like right here. In which case those tracks, they would converge right there. So it's all relative to the height of the viewer, of the viewer's eyes, or the lens of the camera. Okay. And here we have an example of 1-point perspective. Again, just making different cubes. So here we have the horizon line, which represents eye level, and you have a square, or actually a rectangle here that was drawn, here, and here. So you can see that this one that's above the horizon line, we can see the bottom of this cube, and we can see the right side. This one that's below the vanishing point, we cannot see the bottom, okay, but we can see the top. We couldn't see the top of this cube that's above the horizon line. And there's an example of the telephone poles. Perspective was invented during the Renaissance, and this is, I'm not an art historian, and it was a while ago when I made this PowerPoint, but I want to say, well, I don't even know if I want to say, I think this is the Uffizi in Florence, Italy, which I have been to, but I don't remember exactly. I'm pretty sure this is the Uffizi, which is Italian for the word office. It's a very famous building in Florence. And you can see that the horizon line is right here. So the person that made this painting their eyes were right here. This is where their eye level was. And so you see all of these converging lines that are parallel, that aren't vertical, that are horizontal. They all converge at this vanishing point. Two-point perspective is a little different. It's where you have, obviously, you have two vanishing points. They're both on the same horizon. And this is good for showing three-quarter view of like a building or a cube. So in other words, on these examples of one-point perspective, these faces that we're looking at, they are square. This is a right angle. Okay? This is a right angle. This is a right angle. Okay? They're all right angles. When we get down here, it's a two-point perspective. None of these are right angles because you're looking at both the front and the side of something, and you have two different vanishing points. So in the case of drawing buildings, two-point perspective is more real to life than one-point perspective. In other words, if these were buildings, they would look weird. They'd look funny. That's why two-point perspective is more common than one-point perspective. But some of the same rules apply. If this box is above the horizon line, you can see the bottom of it, but you can't see the top. And conversely, this one that's below the horizon line, you can see the top, but you can't see the bottom. Two-point perspective can get really complicated when you start combining different shapes together. And we will do a project where you'll basically create an imaginary city. And by the time we do that, you'll have a much better handle on how to use two-point perspective. And it's really, it seems intimidating at first, and it is. It's tough. But once you reach a certain threshold and it clicks, it'll click. It's so cool. It's so cool. I mean, it's one of those things that this might be the one thing that you remember how to do from this entire class is two-point perspective drawing, because it's so easy to make something look real by using two-point perspective. See, with two-point perspective, you can even make things like windows, a door, I guess, I don't know what, the garage door maybe, the sign. You can even make the letters of the word Joe's using two-point perspective. And we'll go over all that a little bit later. Three-point perspective is not used as much, but it's more accurate to life than two-point perspective. And that's because in two-point perspective, the vertical lines, they are still straight up and down. There's no lean to them at all. So this line right here on this end of the building is parallel with this line and parallel with this line. Well, in reality, they're not going to be parallel, okay? Because in this case right here, with the horizon line being on the top half of the picture, that means that the viewer is standing below this building, just slightly below this building. So, if they're standing slightly below the building, the bottom of the building is going to be closer to the viewer's eyes than the top of the building. So that means that the bottom of the building is going to appear larger than the top part of the building. So these lines really should be going this way. Okay, the bottom of the building is taller, is larger than the top of the building. And an easy way to make this make sense is if you were like in a big city and you were standing below a skyscraper, the top of the skyscraper is going to be itty bitty compared to what you're looking at on the ground, right? And that's what we use three-point perspective for. So here we see an example of all three. Here we have one-point perspective, where all of these lines that are parallel, they all converge somewhere right around here. Okay? Two-point perspective, the vertical lines of this building are still parallel, but the horizontal lines, they recede off to two different vanishing points. This line right here, it goes off somewhere over here off the picture. Actually, it's more like about here, because that same vanishing point connects this part of the building right here, this line. Okay? And then same thing happens over here. The vanishing point is somewhere way off over here, because this line connects with the same vanishing point as this line here. Okay? On three-point perspective over here, we see a lot of the same things. We see this is two-point perspective, because these two lines right here, this line right here and this line right here, they converge off to vanishing points somewhere down here. But the thing that's different between this picture and this picture, the vertical lines that form these buildings, they're not parallel. Okay, you can see that this line right here, it leans to the center of the picture. This line does too, but it leans the opposite direction. And that's because that vanishing point, the third vanishing point, is somewhere way up here. Okay, so this line, this edge of this building, it connects with a vanishing point way up here, and it's the same vanishing point that connects that line right there. Okay? And I have no idea why this picture is here. I put it here for some reason, but it's been a couple years, so I don't remember. So, yeah, I can't remember. So that's it for space.